So let's try to subtract the fraction 1 by 2 minus 1 by 3. In this problem, the denominators are not same. We have 2 here and 3 here, and when the denominators are not same, you cannot just subtract. You need equal denominators or equal units. Why do you need equal denominators? To understand it, let's say if I ask you a question, can you subtract $5 minus 43 cents? Or can you subtract $51 minus 21 cents? You cannot just subtract it and let's say, hey, 51 minus 21 is 30. And 30 what? $30, 30 cents. It does not make sense. You cannot. Dollar is a bigger unit, cents is a smaller unit. They need both to be the same, so you can subtract them. 21 cents is actually 21 by $100. $51 is actually $51. Now you can potentially subtract them. But here we have the same problem. We have unequal denominators. 51 means 51 divided by 1. Our denominators are not the same. One thing we could potentially do is change both the dollars and this one into cents and subtract it. So the basic thing is we need to have the same units, and that is the problem. The denominator represents the units. We will understand it with a graph. Let's say I draw a rectangle, and this rectangle is divided into 2 parts, and each of that part represents one part. So that this shaded part represents 1 by 2. Now let's draw another rectangle and make it into 3 parts. Each unit represents 1, so this represents 1 by 3. To understand it, let's draw 2 rectangles. One rectangle, and in 2 parts, that represents 1 divided by 2's. The denominator represents total number of parts, and the numerator represents how many parts of each of these. Let's draw another rectangle. This time I will divide it horizontally into 3 equal parts. The 3 represents the numerator and 1 represents the denominator. So now we need to add this part with this part. How do we do that? If both those divisions were equal, we could potentially add them. But now each of these equal parts are not of same sizes, so we cannot just add it. There is one way we can make them equal, and that is, what I do is I draw it again. This is shaded part. I divide this one into 3 more parts horizontally, like this. And I divide this one into 2 more parts, like this. Now, the total number of these parts are 1, 2, 3, 4, 5, 6. That's what my denominator is. And the number of the shaded parts now is 3. We have 3 by 6. Remember, this 3 by 6 is the same as 1 by 2. There's nothing we have, the value is not changed. The total area is still same, remains the same. 3 by 6, which represent the 3 fractions out of the total 6, which is the same as 1 fraction of out of a total 2. The same thing here. We have total number of 6 different blocks, and out of these 2 are shaded, so we have 2 by 6. Now each of these blocks, they have the same size. This size is same as this size. This size is same as this size. This size is not the same as this size. Now since the sizes of each of these blocks are same, we can add. And how do we add? We now just simply put 6 in the denominator and just add 3 plus 2, which is equal to 5 by 6. Now how do I get these numbers? What did I do to change this 1 by 2 to 3 by 6 mathematically, not graphically? All I did was I multiplied 2 with the denominator of other 3. So I multiplied this 2 by 3. So basically we had 2 parts, I multiplied it by 3 parts. And once I multiplied the numerator, the numerator automatically needs to be multiplied with the same number to keep the fraction the same. In the same way, what did I do to change 1 by 3 to 2 by 6? I multiplied 3 by the 2 here, and when I multiply the denominator, I need to multiply the numerator also by 2. And that's the thing we are going to do on all other similar fraction problems with unequal denominator.